putting it on the website. Okay, so 5.4 is graphing polynomial functions. Okay, so the first thing that you need to know is what the standard form of any polynomial function looks like. Okay, so I don't know if you can see this, but the standard form of any polynomial function looks like that. So they're saying p of x being your polynomial in terms of x looks like that. So I probably wouldn't write that down personally. Probably should have said that first, huh? But I'm going to give you an example because, I mean, it's technically correct, but it's just very generic. So let me show you an example of a polynomial that's in standard form. Okay, so an example would be, let's say f of x equals 3x to the fifth minus 2x cubed plus 5x squared minus 4x minus 3, something like that. Okay, so hopefully what you're noticing is that as I progress to the right, the exponent gets less and less. Okay, so I did miss the x to the fourth term, so you don't have to have every single degree written, but that would just be an example. Okay, so the way you classify polynomials is by how many terms they have and the biggest degree. Okay, so what is my biggest degree for this particular function? 5. So this would be a fifth degree, and how many terms do you see? 5 terms. You guys see what I'm saying by terms? Like they're separated by plus signs or minus signs. Okay, so this would be a fifth degree. Five-term polynomial. So polynomial, poly meaning, does anybody know what the word poly means? Many. Oh, you guys are so smart. Yeah, many terms. Okay, so they do have abbreviated words for things that are less than 5. So a fourth degree is a quartic. Okay. You would still, if you were working with 4 terms, you would still say 4-term polynomial. Third degree is the same as a cubic. So cubic, 3 terms would be a trinomial. 3 terms. What about second degree with 2 terms? So something x squared. X squared is we studied like them for an entire beginning of this quadratic. So quadratic, if you have 2 terms, binomial. Okay. If you have just an x, let's say your function was 2x, what's x? 1 term is mononomial. That would be a linear mononomial. Okay, so for degrees, you have, if it's just an x, that's linear. So these are degrees. If you have x squared, that is quadratic. X to the third, cubic. X to the fourth, quartic. And you can actually say fifth degree is a quintic if you wanted to. Oh, I forgot to say just a number. Like let's say your number was 5. What's that? Just a number. That's considered a constant. Okay, as far as your amount of terms, so I said terms. So one term is called a mono, how do you spell it? Monomial. Yeah, right? Two terms? Binomial. Three terms? Trinomial. And then after that, they just literally list how many terms. So then you would say fourth termed, fifth termed. So, okay. So, let's see. Okay, so this is kind of an interesting thing. When you're looking at your leading term, the leading term, so when I say the word leading term, do you know which one I'm referencing? The first one, yeah, right? Like mathematicians aren't creative. Leading, the one that's leading the group. Okay, I'm losing all my, what's happening? There we go. So the leading term, so this one right here, we refer to as the leading term. Okay, and so if I say leading coefficient, do you know what the leading coefficient is? The 3. Okay, so leading coefficient is the very first number. Leading coefficient. Okay, so the leading term will tell us what a function looks like. Okay, so if we go to this little table that they have for us, does anybody know what an x function looks like? So if I was going to graph, there we go, y equals x, what does that look like? Linear, right? It's straight line, it has a slope of 1, so it would look just like that. Okay, so anything like that, straight line. So the domain for a straight line is what? Sure. I'm going to say all rails because that's way faster. What's my range? All rails as well. Goes from negative infinity to positive infinity. And for my end behavior, as x goes to positive infinity, what does my right go to? Infinity. And as x goes to negative infinity, what's my left arm going to? Negative infinity. Okay. Anything that leads with an x squared looks like a parabola. Yep, I'm going to give it its official name. Parabola. So can you tell me what the domain of a parabola is? How far to the left, how far to the right does it go? All rails. What about the range? Okay, so on this parent it would have to be greater than 0. What about your end behavior? As x goes to infinity, what's your y doing? Infinity. And as x goes to negative infinity, what's your y doing? Going to infinity. So for x squareds, both are going in the same direction. Okay. What would x cubed look like? What does that function look like? John Travolta, good. So tell me about the domain and the range of a John Travolta. All rails, just like a linear function, right? Okay, tell me about the end behavior. As x goes to infinity, where's the y going? Infinity. And as x approaches negative infinity, where's the y going? Negative infinity. So far, linear functions and cubics have opposite end behaviors. Something to notice. Does anybody know what x to the 4th looks like? Okay.
W.
Yeah, well, it can actually be a W. It can become W-ish in looks. But if I was going to just compare x squared to x to the 4th, you'll start to see something kind of interesting happen. So if I have x squared versus x to the 4th, They both have a parabolic look, so they both are technically parabolas. Okay. Sorry, you guys, the internet is not keeping up with me. My screen is frozen. Oh, come on. Disconnected. Awesome. Okay, so what you start to see is it's kind of like a more rigid parabola. Okay, so it starts out like flatter and then grows quickly. Okay, those values where it's flatter are those values where the x values are fractions. Okay, but anyways, parabolic in nature. So domain is going to be all reals, and your range goes from 0 to infinity, or wherever your vertex happens to land. Okay, your end behavior, as x approaches positive infinity, your y approaches infinity. And as x approaches negative infinity, your left hand is going to infinity. So x to the fourth, both ends are going to the same place, right? Does anybody know what an x to the fifth function looks like?
Is it a John Travolta?
It is a John Travolta, and just a slightly more rigid John Travolta.
And then x to the seventh is John Travolta.
Yeah.
Wow.
Right? Did you catch it?
Wow.
So anything with an odd degree is going to look like a John Travolta. And anything with an even degree looks parabolic. Yeah. So do I need to finish this now that you guys kind of connected that dot? Okay. So, where does this all lay out? Okay, so I don't think I need to fill out this entire chart. You guys tell me. If you put a negative in front of all of these, we all know that the function flips upside down. Okay, it's not going to affect our domain on any of them. The only thing it would ever affect is your range on a parabola. So parabolas would be flipped upside down, so you'd go from negative infinity to 0. But your end behavior, that becomes the most important. So like if we're working with our John Travoltas and we flip upside down, what happens to the end behaviors? They go opposite. Okay, and if I have a parabola and if I flip a parabola upside down, the end behaviors both go down. Do you see where I'm going with this? Okay, so you're going to be like rough sketching polynomials. Okay, so I'll be specifically looking at your end behavior where your arrows are going. And if you have a John Travolta flipped upwards or upside down or whatever the case happens to be. Okay, so one of the really key points in drawing a parabola is knowing where the x-intercepts are. Okay, so an x-intercept, when written in factored form, is where it crosses the x-axis. Okay, so let's do an example. And I'll show you what happens here. This is kind of cool. Okay, so do you guys see, do you see this function right here where it says x squared times the quantity of x plus 1, or x plus 2? Do you see that? Everybody with me? Okay, so before I draw this in Desmos, can you tell me what it roughly looks like? Okay, if I was going to FOIL this out and put it into standard form and look specifically at the leading term, what would the leading term be?
X squared.
X cubed. Okay, so this would be an x cubed function, so I know that this generally looks like a John Travolta. So I have this John Travolta-y look. Okay, now when it's in factored form like this, I also have more information. Okay, remember when we were factoring quadratics and we set them equal to 0? Okay, we are basically finding where it crosses the x-axis. So if I was going to take x squared and x minus 2 and set it equal to 0, where does this function cross the x-axis? Okay, 2. And what else? What about that x squared? If you set x squared equal to 0, what is x? 0. Okay, so this function is going to cross the x-axis at 2 and at 0. Can you imagine what it looks like? John Travolta crosses at 2 and 0. Okay, let me draw it in Desmos and see if we can follow this. So we had x squared, oh nice, and x minus 2, right? Okay. There it is. Oh, there it is. So do you see how it looks like a John Travolta with the end behavior? But what is happening is this function is wiggling. Okay, so it goes up, it comes down, and it goes back up. So how many turning points does this function have? 2 turning points. Everybody understand what a turning point is? I don't need to explain that, like where it changes from increasing to decreasing. So it's like a max or a min, really, or vice versa. Can you tell me the difference between the two x-intercepts? Two things are happening. What is happening at 0 versus happening at 2? Kind of. Okay. 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 I'm going to make up a function really quick. And I'm going to zoom way out so you can't see it until I type it in. I'm going to see if you can follow along with me. Okay, so let's say we have x plus 3 times the quantity of x, whoops, let's just say minus 4. But the second quantity is squared. Okay, so it's graphed over there. Tell me what the graph is going to look like. Give me the general shape of the graph. How many x's? If I was going to FOIL that out, what would my first term be? X cubed. Well, I have an x and then an x squared. So x times x squared is x cubed. So what would it look like? A John Travolta. Where does it cross the x-axis? At -3 and +4. -3, +4. You ready? Watch what happens. This is a very steep John Travolta. You see it? -3, +4. Can you tell me the difference? What is happening at -3 versus +4? Okay, don't give me an increasing or decreasing. I want something different. Okay, I want you to think about the x-axis. Okay, what is happening with the function versus the x-axis? What's that?
Like, what's different about the two different points? Well, at +4, it goes back up, but at -3, it just goes.
Okay. Kind of. I think you're getting there. Getting close. Do you have, what do you think, Dylan? Okay, true. That's just where they came from. We set them equal to 0, so they're opposites. True. But there's something else. Okay, let me try to make up one, like super crazy. I don't even know what this is going to be. I'm just going to make up like a lot of them. So let's say we have x plus, well, that's not an x. X plus 2 squared. x minus 5. X minus 1 squared. And this is going to be crazy. Well, I got a lot of parentheses.
No more x's, please.
X.
Oh.
Let's just say plus 3. Okay. So, what's my leading coefficient? So I have x squared on my first one. There's 2 there. Then I have x minus 5. That's the third. Then I have another x minus 1 squared. That's 2 more. And then I have the x plus 3. What's my leading term? X to the 6th. X to the 6th. What does this generally look like?
Oh.
Okay, it has a parabolic look. Okay, so the end behavior is going to be like this, but we have some x-intercepts. So remember you had that idea of the W? This is going to be like a super W, like a wavy one, like there's going to be more cool stuff happening. Tell me where my x-intercepts are. -2, 5, 1, -3. Good. Okay, watch what happens.
Okay.
Oh my goodness.
Do we have to like graph it by hand?
Yeah,
Or-
and it's actually really easy.
Wherever it's squared, it only touches the x-axis. Wherever it's not squared, it goes through it.
Ooh, say that again. Say that again.
Wherever it's, what was it? Where it's not squared in the function, it goes through the x-axis. Wherever it is squared, it only touches.
Okay, I'm going to use my words this time. But I'm going to repeat exactly the phrase, well, exactly what you just said. Okay, any quantity that has a square or an even exponent. Okay, so at -2, the function is going to bounce. Okay, think of it like a ball. It's going to bounce off of the x-axis. So anything with an even exponent bounces off the x-axis. Anything with an odd, what happens at 5? There's 5. Crosses. Anything with an odd exponent crosses. Even exponents bounce, odd exponents cross. How cool is that? Okay, so let me just make up one for you. Okay, let me see if you can draw this. Let's do x. I'm running out of numbers. -7. Oh, I put plus, that's okay. Squared. And x minus 2 squared. Okay, don't look at it. I want you to draw it on your sheet of paper in front of you really quickly. It says x plus 7 squared and x minus 2 squared. X plus 7, I'm going to draw it over here. X plus 7 and x minus 2. Both of them are squared. Okay, do you guys, oh, am I done? You guys done? I'm done. Done? Okay, so tell me what the leading term would be. Just the leading term.
Oh.
X to the what? X to the 4th power. Okay, so this is an x to the fourth power because you have x squared and an x squared. So x to the fourth. So what does an x to the fourth look like? Parabolic. So I know I have this like, whoa, sorry, I didn't mean to do that. Hands off. Whoa, okay. Sorry. Parabolic in behavior. Okay, but what is happening down here is there's going to be more movement. Okay, so there's going to be some wiggling. Okay, tell me where this function crosses the x-axis. Okay, so -7. I don't know why I can't touch this. It's very finicky today. 1, 2, 7, and 2. 2. Sorry, my 7 looks like a 2. Okay, so what is going to happen at -7 and +2? Is it going to cross or bounce? Okay, it's going to bounce on both, right? Okay, so I know I have this end behavior. It's going to come down. It's going to touch -7 and 2 and bounce. Okay, start at infinity, bounce, come down, bounce, and go back up. Did anybody get that? Yeah? Oh, yeah. Do you guys believe me? I mean, it would be pretty silly of you not to believe me, but... So, there it is. So, this function goes up really, really high because it's an x to the fourth. So, it's incredibly steep. Okay? The exponent makes it so steep. Now, I don't expect for you to find those max and mins, but I want the general shape of your function. So I should look at your graph and say, oh yeah, it's a W. Jenny.
Well, I guess it doesn't matter since it goes with the general shape, but I was wondering, how would you find, like, the max?
Ooh, good question. In algebra, you can't find it. You have to have calculus in order to find a maximum min. So if you take calculus next year, I would show you how to do that. It takes calculus. So for now, we just want x-axis. I want to know general shape is what we're kind of focusing on for this. Okay, so let's see. Should we do, let's see. Do you guys feel pretty confident with this, or should I pick one of these and we can do an example and see if you got it? Feel good? Does everybody feel pretty good, or do you want one more? One more?
Should we be doing, like, John Travolta's?
Yep.
Like that?
Yep.
Can you go over one of those?
Can I make one up? Okay, this is the test question. Do you got it or do you don't? Question 2, test. Not really, but if you can do this one, then I feel confident that you got this. Okay, let's say we have a negative. I'm going to put out x squared, x plus 2, x minus 4. Oh wait, you said John Travolta. Squared. Perfect.
No.
Okay, draw it. Okay, so figure out what it generally looks like, and then figure out where it crosses. What is happening is, are they crossing through, or is it bouncing? And see if you can draw this general shape. Pretty sure my question is like harder than the ones on the assignment, just so you know. I get a little excited about this stuff because it's cool. Okay, are you ready for me? Okay. So tell me what the leading term is. Negative x to the fifth. Negative x to the fifth. So if I have negative x to the fifth, generally what does this look like? John Travolta, what does the negative do? Flips it upside down, right? So as far as my end behavior, I should have a right arm that's going down and a left arm that is going up. Now what happens in the middle is that little piece is going to be some wiggling. Okay, but at the end, I should have a left arm going down and a right arm going up. Okay, so now tell me what the x-intercepts are. Okay, -2, 4, and 0. -4. Okay, now tell me what is happening at each of those. So if I have x-intercepts, they intercept at 0. Tell me about 0. What is happening when we get to 0? It's a bounce. Okay, it has an even exponent, bounce. When we get to -2, what happens?
Crosses.
It's a cross, crosses. When we get to 4, what happens? It's a bounce. Okay, you ready? I'm going to go left to right. Left to right. So my left arm is where? Left arm is right here, so my left arm is up. Okay, so I know, yes?
How did you get the 0?
0 from x squared. If I set x squared equal to 0, x has to be 0. That makes sense? Okay, so left arm is up. Okay, so I'm going to come from positive infinity, and I'm getting sucked to this x-intercept. Okay, so now when I get to -2, what's going to happen? Is it going to bounce or is it going to cross?
It's going to cross.
Okay, so cross, right? So it's going to come and it's going to cross through -2. Okay, now I know I have to come back to my next intercept. When I come back up to my next intercept, what's going to happen?
Bounce.
It's going to bounce. So it's going to come up, bounce down. Okay. And I'm coming back up to my third one. What's going to happen off my third one? Bounce, and it's going to go back down. Okay. Did you draw it? So it comes from infinity, crosses -2, gets sucked back in, bounces. This one's going to go lower because there's a bigger distance between the two. Sorry, mine's not very symmetrical. And then it's going to bounce and go back down. Does that make sense? Okay. Do not worry at all about how high or how low these maxes or mins are. We're not playing that game today. Hopefully we will eventually, because that's kind of fun too. But everybody good? Okay. Do I need to talk about like end behavior and how many turning points this has? So, how many turning points do you see? 4. So I see 1, 2, 3, 4 turning points. Right? So a turning point is technically like a max or a min, relatively. Right? 4. Okay. Good? Okay. Let me double check, make sure I covered everything. Polynomial. Oh yeah, we got it all. Ooh, okay. All right, so your worksheet is in Google Classroom. Okay, so again, it is up to you if you just want to pull it up and write it on a separate sheet of paper, or you can do it in Cami and turn it in electronically. Completely up to you.